Hey guys, welcome back to my series of videos of me solving LeetCode problems. Now we're solving 238 product of array except self. Given an integer array nums, return an array answer such that answer of I is equal to the product of all elements of nums except nums I. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. You must write an algorithm that runs in on time without using the division operation. So, I already went for this, and I wrote a non-on. I wrote an n squared complexity algorithm. So, and pretty much the algorithm was, I'm gonna open JS Paint and show you. So the algorithm was something like, let's imagine we had an array that was 1, 2, 3, 4. And we wanted to do the positions. So we wanted to return an array of 4 positions, where this would be 4 times 3 times 2. So I would just go for the first one, let's iterate over everything and multiply. So 4 times 3 times 2 is 24, because 4 times 3 is 12, 12 times 2, 24. So 1 times 3 times 4 is 12. 1 times 2 times 4 is 8. 3 times 2 times 1 is 6. This is the result, and this is the algorithm that I coded. So as you can see, I have 2 cycles here. I check if the indexes are the same. If not, I just multiply, then I return the array. They pass the test cases, but then they will have a timeout when it comes to one big case, which is expected because they ask us to do something in on time. So I was researching, saw some solutions, and the approach to do it is, let's say you want to save multiplications that you will do again. So let's say you want to multiply, you want to get the value of this index. So it's 3 times 2 times 1, which is 6. That's cool. So, and then you know for a fact that here the value will be 6 at this moment. But what is the value that is here before 6? The value is 2. And the value before, in that multiplication, before that it's 1, because it's 1 times 2 times 3 is 6, 1 times 2 is 2, 1 times itself 1, and then we have another place here, so let's just put a x for now. And now we can do the opposite thing. So we want to know what is 2 times 3 times 4 and put it here. It's 24. And now 4 times 3 is 4, 12. And then 4, because it's 4 times itself. And then we have x. So I'm even going to put some commas and clearly separate the values so we understand what we're talking about. So now we know. Let's look at the solution for this. The solution we already know is 24, 12, 8, and 6. If you look closely, 24 is already here, so it's good. 12 is already here, but we have this 1. Then it's 8, which is 4 times 2, and then we have 6. So if we replace this both with ones, we can see that the final result is this times this, this times this, this times this, this times this. So it is 24, 24 times 1, 12 times 1, 8, and 6. So, given this logic, let's implement it. So left accumulator is equal to 1 multiplied by, actually we don't even need to do that, don't need to multiply, and then, yeah, but let's do it just to make it clear, times the length of nums. So we start with an array just of ones, right? Accumulator is the same thing, 1 times the length of nums, and then we do for I in range 1 until length of nums, left accum of I equals nums of I minus 1 times left accum of I minus 1. That's the first thing. Then we do the same thing for the right one. But in this case, we're iterating through length of nums minus 2 all the way to minus 1. The step is minus 1. So this means we want to go to 0 inclusively. So right accum of I equals the nums of I plus 1 times right accum. And now to end this, for I in range length of nums, now we can replace the nums array we have. Nums of I equals left accumulator of I times right accumulator of I. Then at the end we just return nums. Let's run this. It works. Submit. Okay, it worked. Beats 47%, beats 31%. Let's submit again and see if we get a better result. Oh, it was the same. So I am satisfied with this for now. Hope you guys enjoyed it.